Hi everyone, David Blakey here. The title of this video is Python Complex Data Structures, also known as multi-dimensional data structures. So let's begin with a little terminology. What is a data structure? What do we mean by data structure? Well, simply enough, we've been calling them by some other name, but a data structure is any object in Python that holds data. So you can see that this string object holds the string letters HELLO, or this list holds these numbers. And so any of these is a data structure. Any of the types of objects that we've looked at so far, which were integer, float, string, tuple, list, dictionary, any of these can be termed data structures. And data structure is a somewhat more generic term for any of these types of objects. And we use that term across languages. But in Python, we're talking about objects that hold data. And of course, that's part of the definition, but we're talking more specifically about the basic structures. And a complex structure would be one that holds something more complex. Now let's look at this object, this initialization of something, and ask first, what type of object is it? Can you tell from what we're looking at? Well, you can see that it says label equals, so Super Bowl wins equals, label equals, and then a square bracket. So the first thing you want to think when you see something equals square bracket is, perhaps this is a list. I'm not saying that it's always the case, but it almost always is. Certainly is in this course. If you see label equals square bracket, and then somewhere inside you see some commas, you can be pretty sure that you're looking at a list. As you know, a list just normally looks like, 1, 2, 3, 4, 5 inside square brackets. This is obviously a little bit different, but let's look at it a little more closely and see what we can see. We've got a square bracket, and then we've got another square bracket. Well, that's strange enough. But then if you look closely at the beginning to end square brackets here, it looks like another list. We've got a string, comma, another string, comma, and another string. And that looks like a list. Then we've got a closed square bracket. Then another comma. So that's a little confusing, but as you can see, because of the way I lined it up, this is a list of lists. Each element in the outer list, Super Bowl wins, contains another list, which we could call an inner list. So if I were to ask you how many elements in Super Bowl wins, you would not say 27. That's how many strings we have in this entire structure. What you would say is 9, and the reason you'd say 9 is because there are 9 lists in Super Bowl wins. Now those lists happen to point to other elements, but that's sort of beside the point. Super Bowl wins contains 9 lists. Now we can access those lists by going into Super Bowl wins, but they're really just attached or contained within Super Bowl wins by reference. So Super Bowl wins doesn't actually contain all of those strings. It just contains those lists, that is the reference to those lists. We're not going to talk about references here, but we have talked about it in a previous video, I think. And in any case, we can say that Super Bowl wins contains 9 lists, and that we could access each of those lists individually through Super Bowl wins. So what do we do with a structure like this? Why do we have it arranged this way? Well, this type of data arranging is really quite common, and you've seen it many times in the past in this class, and you've probably seen it many times in your life. A data structure like this, sorry if you're watching this in the dark and that was pretty bright. A data structure like this is something called a colon separated values file, or a character delimited file, and it contains the same type of information that we were looking at here. We have a bunch of records, that is each line in this file. This is a text file. Each line of the text file contains a record of information that is something about a particular, let's say, a particular person. It looks like we've got an ID in the first field, an address, a city, a state. I mean, you're quite familiar with this, I know, because we've been going over it. But this sort of formatted data is very common. It's tabular data. Another example of tabular data is an Excel spreadsheet. Here I've just filled in some of those elements just to show you that an Excel spreadsheet also contains records and fields. Here it's lined up a little more conveniently. The record contains information about a particular person, that is their ID and their address. And each record is about a single person, and each field is a piece of that data. So it's quite easy just by going to the particular element, like this is cell C2, to look at a particular piece of information about that person. You might go to the second record to learn about AXE99's information. And if you wanted to know what city they lived in, you'd go to the third field to see it. So similarly, we'd be looking at our data this way too. This particular data is organized in the same sort of way. We have a list of lists. And the other two ways I showed it to you are really the same thing. A last structure that we can talk about that also makes use of a list of lists is a database. Databases are called relational, not because they have data relate to one another, but because they store data in tables, very much like the spreadsheet, or even like this list of lists that we've got right here. A database table is made up of columns and fields, right? Or rather, rows and columns, or records and fields. It's all the same. The reason it's called a relational database, by the way, is that in math, a table is known as a relation, presumably because it relates. You can look at data from column-wise or row-wise and relate one sort of type of data to another, or one sort of category of data to a record. I suppose that's why they call it a relational database. That's why they call it a relation. A table is like a relation, not like a relative, but it's like a mathematical construct called a relation. And that's why databases are called relational databases, as opposed to something like an object database, which stores its data in objects. For our purposes, we're going to see about putting the data that we get from a database, a text file, or an Excel spreadsheet even, and putting it into a structure that we can use ourselves and then we can access quite easily. This is a list of lists, and we created it by simply stepping through a data source and then creating a list that we can then add to an outer list. We'll learn how to do that a little bit later. For now, we can access any piece of this data by simply going into the second dimension. That is, referring first to the list that we want to talk about, and then talking about which element of that list we want to access. Let's say we want to talk about Miami. Well, we know that Miami is in the last element of Super Bowl wins. But maybe to make it a little clearer, let's say we wanted to talk about Pittsburgh. We'll begin by referencing the list that is the first element in Super Bowl wins. What's the first element of Super Bowl wins? It's this entire list. If we print Super Bowl wins 0, what are we going to get? Let's find out. We get a list. You see how we get a list there? We get that first element, the entire list. That's what Super Bowl wins is. It's Super Bowl wins 0. The first element is that entire list. So what if we want to print out, let's say, the name Pittsburgh? Well, we know we have access to this list because there's the list right there. It's in Super Bowl wins 0. So if we wanted to take the second element of Super Bowl wins 0, we would simply add another subscript. We're simply saying whatever Super Bowl wins 0 points to, give us the second element of that. That's what the index 1 gives to us, the second element. And that's when we get Pittsburgh. So you can see it's quite easy to access data within a two-dimensional structure like this by simply combining subscripts. All we're doing when we say Super Bowl wins 0 is give me the first element, that's the list. And then when we say give me the second element of that, we're saying give me the second element of that first list. So that's how we can get through a two-dimensional structure quite easily. Let's look at another structure that's similar. In fact, it's the same data, but it's organized differently. What is this? I'll give you, you should pause, maybe see if you can figure out what this must be. I've stretched it out a bit to make it a little more readable, but take a look. Pause this video and see if you can tell what this is. Okay, you unpaused? What is this? What is this? Well, it's called dodicts, so that's not telling us much. But you can see that that dodicts equals a curly brace, right? So similar to what I said before about a label equals a square brace, which would indicate a list, what does a curly brace indicate? What does a curly brace indicate? It indicates a dictionary, right? We know that, for example, if you wanted to create a simple dictionary, you would simply use you'd use curly braces. Here's a one pair dictionary, right? This colon that. And if we wanted two pairs, we'd say this colon that, this colon that. Great. So there you go. We have key is associated with value, comma, key is associated with value. Terrific. So what have we got here? Is it a dictionary? It's a good question. Just because you see the curly brace doesn't mean that you should necessarily assume, but let's take a look. After the curly brace, we have a string, then we have a colon, then we have another curly brace. Well, it's starting to look like a dictionary. Let's look at that dictionary again. We've got string colon integer, comma, string colon integer. What have we got here? We've got string colon, what's this? I like how Vim, that is the VI editor, will highlight the other brace just to keep us clear and honest. We've got curly brace, string colon string, comma, string colon string, end curly brace. Well, by gosh, it looks like another dictionary. And it is another dictionary. So what have we got here? We've got a string key, which is associated with a dictionary, and then another comma, right? Then string colon dictionary, string colon dictionary. If you just consider that we're, in a sense, replacing the integer or the value of whatever is associated with the key, we're replacing that with a whole dictionary. You can see that this is a dictionary of dictionaries, where the key is a string, as it almost always is in dictionaries, and the value is another dictionary. So why is this useful? Well, it's really extremely useful, because if we were to very easily, as we would very easily, store this data in a dictionary of dictionaries, that is the same data that you can see here in kind of tabular form, the same data that we had listed that we could have listed in other forms like a database, an Excel spreadsheet, or a colon separated values file or a comma separated values file. If we take that data and we store it in this dictionary of dictionaries, we can now look things up really easily. Remember that another name for a dictionary is a lookup table. When you have a two-dimensional dictionary like this, it's really, really easy to look things up. Now, this assumes that we know the name of the team. We could have made the key for this dictionary. We could have been the city that the team is from, and that might have made it maybe a little bit easier. But generally speaking, when we're talking about this formatted data, usually the key or the identifier for any record in the data is an ID of some sort. So you can see we're not relying on the person's name, because oftentimes names are not unique, right? There might be another David Blakey in NYU. So we have unique IDs that we use to identify ourselves. Otherwise, we'd all be using our names for identification, but we can't, right? Social security number is another unique identifier, so is email address, right? But here we're using an NYU ID as a unique identifier. Okay, so in this case, with this data, with the teams and the wins, we're also using a unique identifier. We just used an integer. So maybe we're interested in finding out how many wins Los Angeles had. How would we do that? Well, you'll remember that in order to, is it called dodict? Let's see. Dodicts. So you may remember that in order to look something up in a dictionary, we use the same syntax as we did with a list. We use square brackets and the key. The key, giving the key to a dictionary gets us the value. And what's the value associated with 8? It's a dictionary, right? 8 is associated with a dictionary. The value associated with the key 8 is a dictionary. So if we print it out, we should print it. That would help. Oops. Oh boy. Let's see if we can redo. There we go. If we print dodects 8, what do we get? Let's clear first. Clear. We get a dictionary with two key value pairs, same as we saw initialized. So that makes perfect sense. When we print dodicts 8, we get the dictionary that's associated with the key 8 in dodicts. So what if we wanted to find out how many wins Los Angeles had? Of course, we're beginning again with the assumption that we know the ID for Los Angeles, and we could make this a little more user-friendly and say that the key would be the name, the city that the team is from, since those will always be unique. Or will they? What if a team moves out of a city and another team moves in, and we're really in trouble? Usually, to be safe, we'll use an ID, right? Let's say we want to know the city, and then we want to, after that, learn the number of wins. So you can see we're using the exact same syntax that we used with the list of lists. A list of lists gives us subscripts, and we can combine the subscripts to get into an inner dictionary through an outer dictionary. Here we're doing the exact same thing. We're accessing the inner dictionary. I'm sorry, that was inner and outer lists. Here we're doing the exact same thing. We're accessing an inner dictionary using a key, and then we're accessing information within that dictionary using, again, the key of the inner dictionary. So we're seeing team 8 and the city for team 8, and then give me for team 8 the number of wins for team 8. You can see how easy it is to look something up. You can see Los Angeles and 3. Perfect. That's exactly what we want. Now you just need to use a little bit of imagination to think about applying this information, applying this tool to information that you have at your place of work or at home. Of course, everyone has information at home. I don't know if you organize your information using Python scripts, but I sometimes do. And it's not totally unheard of. We all have information to gather. Perhaps you want to store all your tax return information or something like that. You might want to store it in some sort of database. It's not unheard of. I know it sounds a little geeky, but it could be really useful. Long before I had any idea of how to find the largest files in my file system using Mac or PC, I had a Python script that did the same thing. Before that, I had a Perl script that did the same thing. There's lots of uses for technology in your own lives. Don't be ashamed. Here, we're talking about, though, information that you might have at work. And your information can run the gamut, of course, but we're all dealing with structured information in our places of work. If we're in the IT department of our place of work, we have tons of information that we may want to store. I worked at Condé Nast once, and they had I think I mentioned this in class, and they had information stored on horoscope. Now, how would you store a horoscope in a data structure? What if your program was designed to open up a database, find out and loop through all the users that wanted their horoscope, and then find out the horoscope for today for this person's sign? So you would go through the database, you'd find user 1. User 1 is a Gemini, and then you'd want to find you'd want to send out the horoscope for Gemini for today. How would you find that? Well, your program could easily have a structure that begins by storing all of the data for the horoscopes in a structure. And when you search for it, you might say something like this: print horoscopes, today's date, and then Gemini. Now you might be asking, why wouldn't, and then presumably this data would be stored in a dictionary of dictionaries that has the key is the current date, and then associated with that key is a dictionary of 12 horoscopes for that day, each key of which is one of the horoscope names, one of the zodiac signs. So you might ask, well, why don't I just use a database for this? Well, look, if you're looping through 100,000 users, as I did on the job at Condé Nast, and you're in the morning, and you want to pull out numerous horoscopes for this particular day, you're not going to want to hit the database 100,000 times just to get the same horoscopes over and over again. Instead, you'd hit it 12 times or one time to pull out all the horoscopes for the day, and you'd store it in a dictionary, and then you'd use that dictionary within your program. So it's quite common to want to pull out information from a data source like a database, store it in an intermediate structure like a dictionary of dictionaries, and then just use that dictionary of dictionaries to pull out the information as you please. Hitting the database all the time can be extremely impractical. So I hope I haven't gone too far off the mark by going through some real-world examples, but I'm just trying to make the case for you for why you should be learning this aside from just doing the assignments. Here we have a dictionary of dictionaries, and we're pulling this information out using the key and then an inner key. Remember, when I talk about these different structures and I want to talk about, let's say, an outer list and an inner list, you can see what I mean. I usually, when I write it in the handout, I put outer and inner in quotes because they're not really outer structures and inner structures. But we do know that Super Bowl wins as a list refers to some other lists, and we can think about those lists as being inner lists, as if they were inside the outer structure. Same thing with dictionaries. We have a dictionary here where the keys are a string and the value associated with each string is another inner dictionary. So that's us getting particular information out of a particular two-dimensional structure. What if we wanted to loop through the structure? What if we wanted to loop through the structure? Well, we can do it really quite easily. Let's say we wanted to loop through this Super Bowl wins database and pull out all of the names of the teams and the number of wins. Quite easy. And let's try it. In fact, let's begin by looping through the whole thing. Well, no, I'm sorry. Let's be more practical. For a team in Super Bowl wins, we could test this by saying print team, but you know what we're going to get. We're going to get each list in the file, each list in the outer structure. But maybe we're not interested in that. Maybe we want to say, let's say team 1 had team 2 wins. Maybe calling it team is not the right one. Let's just say for row. And let's see what we get there. A mistake. What's the problem here? Invalid syntax. Okay, I think I missed a plus. Let's try it again. Clear. Again. EOL while string is trying to literal. Oh, I did not end the quote. Okay, great. Great. Try again. See, even the instructor makes mistakes. I don't mean to disillusion you. My goodness. I guess wins also needs to be a complete string. Good Lord. What am I doing wrong? Oh, I see. Okay. Well, I would edit this, but I don't have time. Do it later. Okay. Pittsburgh had 6 wins. Dallas had 5 wins. San Francisco, etc. So we got through the entire structure, and we were able to pull out particular pieces of information. Obviously, you know that row contains a list, or row is a list. Since we're looping through Super Bowl wins, we're looking at each list individually. And then since row is one of those rows, and it has 3 elements in it, we're able to take subscripts of that inner list. Simple enough. What if we wanted to look through every element? Well, since row is itself a list, we could say for element in row, print element. What we're going to get then isn't quite as clear, but as you can see, it's giving us every element in the entire data structure, and it's printing each element on a single line. We could go further and put a comma there. That'll put a space after each one. That would give us quite a jumble. If we were to just print one extra line after each row, then we would get something that's a little more comprehensible. No, it's not exactly what I wanted. And I can't say why I'm getting that, but I'm just going to leave it for now. Okay, great. So, oh, I think, no, I still don't know why. Oh, I see, because it's saying comma. We want to put the print out here. That's the reason, of course. We're just going to put in an extra line for each row. There we go. Awesome. 1, comma, Pittsburgh, comma, 6, right? So comma, as you know, adds a space after each print. Then after each row, that is every time we loop through an entire row and we come back to here, we're going to add a line. That's why we get all our data in a nice readable row format. Okay, that's looping. That's us looping through a list of lists. And I just want to emphasize this one more time. If you say for row in Super Bowl wins, what's a row, right? It's one of these lists. So if you then say for EL in row, print EL, you're going to get each element separately. So you'll get 1, then Pittsburgh, then 6, then 2, then Dallas, then 5. Because this is a loop within a loop. We're looping through each row and then we're looping through each element. So it's kind of like a wheel within a wheel. And you want to, when you're thinking about two-dimensional structures, you often have to think in terms of a two-dimensional loop. It doesn't mean you always work this way, but you do understand that since we're talking about a list of lists, we can loop through the outer list, and then for each row in the outer list, we could loop through the inner list. So it's quite simple to get to each element this way. Any questions? All right, let's try a dictionary with the same thing. Now we have a dictionary of dictionaries. Let's loop through the dictionary of dictionaries. If we are talking about a dictionary of dictionaries called Dodicts, let's loop through it using keys. We'll say for key, or let's say for ID in Dodicts. We could say just colon, but we'll just say keys just to make it clear. And then if we printed ID, what would we get? We'd just get a list of the keys, right? We would just get each key one after the other. Oh my goodness, why are they out of order? Why? Because the dictionary doesn't care about order. But if we did want to loop through everything, we have the key. So what would get us to the inner dictionary? Well, it would be print Dodicts Dodicts ID. And let's see what we get there. And actually, I'm going to do another print statement here just to clarify. So we get the key, and then we get the dictionary, which is the associated value, right? So you see key is an integer, or it's really just a string with a number in it. And then the value is the associated dictionary, the dictionary it's associated with. Okay, so what if we wanted to loop through that inner dictionary? Let's do it. We've got Dodicts ID. We know that that's a dictionary. Let's treat it as a dictionary. So we're going to say for, let's say for inner ID, or let's just say key, for key in Dodicts ID. For key in Dodicts ID, print key. And why don't we print the value as well? Well, let's just print the key. Let's see what we get. Ooh, that's a little confusing. Let's do a print statement after each sort of row, as it were. Another clear. Okay, we get 4 city and wins, 5 city and wins, 2 city and wins, 7 city and wins. Why are we getting this? I'll just point out that you always want to be able to look at your code and decide why you're getting what you're getting. Well, first we print the ID, which is the number, right? So we're getting 2, 5, 4, etc. Then we loop through Dodicts ID. So what is Dodicts ID? We could have said Dodicts ID.keys, and that might make it clearer. Dodicts ID is the dictionary, right? It's the dictionary that's associated with this string key. So if we say Dodicts ID.keys, we're asking for the keys within that inner dictionary, which is why we're seeing city and wins. So what if we were to loop through that as well? Well, we are looping through it, and we're getting the key. So why don't we just go ahead and print the value associated with Dodicts ID key. Dodix ID key. Ooh, now we're really getting jiggy, as they say. Let's do a clear. 7, city, Washington, wins 3. Okay, why don't we just associate these two so that they're a little clearer in the output. Okay, so now we're saying key equals value. 5, city equals New York, wins equals 4. 4, city equals Green Bay, wins equals 4. 7, city equals Washington, wins equals 3. We're getting the entire structure printed out. We could go even further and just indent a little bit to make it a little clearer. And now you're seeing that team number 7, the city for team number 7 is Washington, and the number of wins that Washington won was 3, etc., etc., etc. So this is us looping through the entire structure. Let's look through this one more time just to clarify. We're saying for ID and Dodix keys, right? So each ID is going to be the string key. That would be 10 or 9 or any of the string keys that we have. We're saying for ID and Dodix keys, we're getting the string key, right? Then we're saying for key and Dodix ID keys. Well, what's Dodix ID? It's the associated dictionary, right? The associated dictionary to Dodix ID, Dodix 10, for example, is this dictionary. Dodix 9 is this dictionary. Excellent. That gets us a dictionary. What we're looping through when we say Dodix ID keys is we're looping through the keys of the inner dictionary, city and wins. So key is going to be city or wins or city or wins. There's only 2 of them for each dictionary. So when we say print key and then Dodix ID key, what's ID and key? Well, ID would be 10 and key would be city, for example. Or ID might be 9 and key would be wins, for example. We're seeing all of them. That's why we see key, city, equals the value, New England. Key, wins, equals the value, 3. And that's done for each key in the outer dictionary. And that's us looping through a 2-dimensional dictionary. Okay, last bit. How would we build this stuff up? I have to put a little bit of a key in this YouTube video. It's getting to be so long. How would we build this stuff up? What if we had a structure like this and we wanted to build a dictionary of dictionaries or a list of lists? Let's build a dictionary of dictionaries since it's a little more challenging. Check out what we've got here. What have I got here anyway? It's good, and if you feel like testing yourself, pause the tape in a second, pause the video, and what I'd like you to answer is, what is this structure? What is file lines? What type of structure is it? And then, or what type of object? And then what does it contain? What types of objects does it contain? Okay. All right, so what is it? What type of object is it? File lines is a list, right? It's a list. It starts with a square bracket and it has objects with commas between them. That's a list. That's what a list is, right? That's how we express a list in our code when we want to initialize the list in our code. And what types of objects does this list contain? It's string objects, right? Don't be fooled by the colons. Those colons are within quotation marks. So the quotation marks mark a string, right? Begin quotation mark, end quotation mark, and then inside of it, colons. So what is this exactly? Well, shield your eyes. I'm about to switch over to this. It's like a colon separated values file. I'm just putting it into a list so that it's visible. If I were to open the file and read it, it would look like this anyway. So if I were to say open file ex1.txt and then for line and files, or I would be getting file lines. You'd see file lines, right? It would look like this because when you open a file, you get a string for each line. Okay, great. So we want to build a dictionary that's similar to the dictionary we saw above, which was this dictionary, where the key is a string and the value is a dictionary. And we want to build it up, and maybe we'll build it up a little more selectively. Let's just have each dictionary key point to a dictionary that is the city and the number of wins. In fact, you know what? Let's make a list of dictionaries. All right, that's what we're going to do. Something that's a little bit different that doesn't give you the immediate answer to one of the homeworks. But, okay, so the object will be to create a list of dictionaries. What would that be useful for? Well, maybe we're interested in, we always know we're just going to be looping through all of this pieces of information, but we do want a useful, a very handy dictionary for every element that we loop through. Okay, fair enough. We could sort these dictionaries by a particular element. We'll go over that in another video maybe. But what we're going to do now is create a list of dictionaries, right? And then we're going to say that the inner dictionary should be key equals city and value equals wins. What do I mean by this key equals city and value equals wins? I just mean that the key will be the city and the value will be the wins. So the dictionary will be something like this. Well, it'll just be city and then wins. Maybe this dictionary isn't as useful as I thought, but we'll try it out and just see how it works. So the inner dictionary will be city and wins. So we want to loop through this information and make a list of dictionaries. So how do we do that? Well, we're going to begin by creating an outer list, right? Anytime you're looping through this stuff and you're going to be building up something as you go, you're going to want to begin by declaring that structure. So we're going to say outer list equals list, empty list, right? Now we're going to say for line in file lines. This would be like looping through the file. We're going to split our information, right? We're going to say elements equals split, line dot split on the colon. If we were to print elements, we could see what we get. We get a list of these elements. This looks like similar output to what we've seen before. I'm just gonna print. I think I'm just gonna print hello first, just to show that this is exactly what we're looking for. There's hello. Okay, so we know that this is what we want. Okay, so we now have these elements in this list called elements. And now I want to create this dictionary inside that I'm going to now add to outer list. So we can say myDict equals elements 1, which would be the city, and then elements 2, which would be the number of wins. Just add a little space to make this a little clearer. So what are we adding here? We've just created a dictionary with one key and one value. The key is the city name. The value is the number of wins. We got that from elements, which we got from split. Okay, you can see what elements contains. Any given elements contains this list of 3 elements. And when we say elements 1, we mean the city. And when we say elements 2, we get the number of wins. And that's what we put in the dictionary. Now, how would we add this to the outer list? If we wanted to create a list of dictionaries where the inner dictionary has the city and wins, we now have our inner dictionary, myDict. How could we add that to the outer list? Well, how do you add anything to a list? Do you remember? It's a method called append. And we can do it quite easily by simply saying outerList.append myDict. Wow. Let's check it out, see what we got. Let's print outer list. Let's see what we got. Okay, that's going to be hard to read, but let's take a look at it anyway. Take a good solid look at this and tell me what you see. What sort of structure are we talking about here? Well, you can see it's a list, or it looks like it might be a list. We can't always assume, but there is the square bracket. Then you can see what is clearly a dictionary, just one key and one value. And then a comma. It's a list of dictionaries. It's exactly what we wanted. we could go further just to clarify and say for EL in outer list, print EL. Then if we do that, we'll see each dictionary printed line by line. And that's because we created this special structure, a list of dictionaries, and then we looped through it just to see what we got. Now again, why would we want something like this? Well, again, maybe we're interested in building this up just so we can loop through and display it in some way. So we might say then print, let's say, what are we going to say? Whoops. City EL has EL wins. And I didn't mean EL, I meant, well, each one's a dictionary, isn't it? So you could say for EL in outer list, and that's a dictionary, isn't it? So I guess if it's an inner dictionary, we're going to have to loop through. Or if we've got the dictionary, well, all right. I'll be the first to admit I created a very impractical structure. Now, if you're interested in seeing a YouTube video on a more practical structure, I can certainly do it on request. This video is so long, I'm not even sure if anyone got this far. If you did, send me an email saying, I got this far, and you'll get an extra credit. Just kidding, but it would be fun to hear from one of you that actually got this far. And I have shown you an example of building a list of dictionaries. Not terribly practical, but certainly does use the same techniques that we would use to build, let's say, a dictionary of dictionaries or a list of lists. If you do want a demo of building a dictionary or a list of lists, I certainly will do that, but I'm going to close this YouTube video for now and say, hope you have a great night. As you can see, it's 8:04 p.m. and it's time for dinner. I'll see you next class, and I hope you enjoyed the video. Please do let me know how they are striking you.